Good morning to everybody. Today I am taking class on basic operations on signals. Here operations on independent variable and dependent variables. Independent variables are time and spatial coordinates, and dependent variables are amplitude, scaling, multiplication. These are the dependent variables. First let us see the operations on independent variable. First one here is, that is, in this I have time scaling operation. Time scaling operations. Let x of t be a continuous time signal and y of t is a scaled version of x of t. That is represented as y of t is equal to x of at. Let x of t be a continuous time signal. Its time scaled version is represented as y of t is equal to x of at, where a is the time scaling factor. Let us take that a is greater than 0. If a is greater than 1, if a is greater than 1, then the signal x of t is compressed. Then x of t is compressed. That means y of t is the compressed version of x of t. Y of t is the compressed version of, that is, y of t is the compressed version of x of t. That is, let us take that y of t is in between, if it is in between 0 and 1, then y of t is the expanded version of x of t. If a is in between 0 and 1, for example a is 1 by 2, 1 by 4, then y of t is the expanded version of x of t. For example, if signal is like this, suppose if I have one signal like this, this is -1, this is +1, this is 0, this is t. If this is x of t, if I take that, if a is equal to 2, then y of t is equal to x of 2t. In that case, to get the value of -1, t must be 1 by 2, and to get a value of 1, t must be plus 1 by 2. That means, that is, at t is equal to 1 by 2, we'll get y of 1 by 2 is equal to, I'll get x of 1. When t is equal to minus 1 by 2, I'll get y of minus 1 by 2 to x of minus 1. That means which is there from minus 1 to plus 1, that is mapped in between 1 by 2 to plus 1 by 2. Then the signal is, shape of the signal will not change. This will become minus 1 by 2, this is 1 by 2, this is t, this is 0, this value is 1. This is the y of t. That means y of t is the compressed version of x of t. See here how it is compressed here. This width of this signal is minus 1 by 2 to plus 1 by 2. Width of signal is 1, but width of this original signal is minus 1 to plus 1 is 2. Hence the signal is compressed here. That means what you should do here is, when time scaling factor is greater than 1, in that case just you divide this time axis by that scaling factor. Here scaling factor is 2, that is minus 1 divided by 2, minus 1 by 2 will get, 0 by 2 is 0, 1 you divide it by 2, it will become 1 by 2. Okay, this is how the signal is compressed. Suppose if we take a is equal to 1 by 2, it is in between 0 and 1. In that case, that is y of t is equal to, you will get x of 1 by 2 into t. Now let us check at what value of t will get the upper and lower limits of this our original signal. When t is equal to plus 2, you will get, that is y of 2 is equal to x of 1, y of when t is equal to, minus 2, y of minus 2 is equal to x of minus 1. That means signal which is there from minus 1 to x of minus 1 to plus 1 is mapped from y of 2 to y of minus 2. That is, signal is, this is minus 2, this is plus 2, this is 0, this is t, this is 1. This is the y of t. Now, since the time scaling factor is in between 0 and 1, y of t is the expanded version of x of t. How it is expanded? Width of this signal is minus 2 to plus 2 is 4. Original signal is width is 2. Hence the signal is expanded here. That means in time scaling operation, signal can be compressed or signal can be expanded. If the time scaling factor A is greater than 1, then the signal is compressed. If it is in between 0 and 1, then the signal is expanded. Okay. A very simple way of doing this is, if the time scaling factor is greater than 1, then what you should do is just you divide the time axis by that scaling factor. Minus 1 divided by 2 minus 1 by 2 plus 1 divided by 2, it will become 1 by 2. You will get the next compressed version of that signal. If it is in between the 0 and 1, if the scaling factor is in between the 0 and 1, just to multiply that time axis by the scaling factor. Now denominator of that scaling factor. Denominator of the scaling factor is 2 here. Multiply this time axis of this x of t by this denominator of scaling factor. Scaling factor is 2, multiply by 2, it will become minus 1 into 2, you get minus 2, plus 1 into 2, it will become plus 2. Okay, here signal is expanded. Okay. Next operation here is, we have time shifting operation. The second one is time shifting. That is, let x of t be a continuous time signal. Shifted version of this signal is represented as x of t minus t naught. X of t minus t naught. If t naught is positive, if t naught is positive, then y of then x of t is shifted to the right side. X of t is shifted to the right side by t naught units. Then x of t is shifted to the right side. If t naught is negative, then x of t is shifted to the left side. For example, if you have a signal like this, if this is the signal, this is 1, this is 2, this is 3, its maximum value is 1. This is x of t, sorry, this is t and this is y axis is the x of t. Suppose if you take that t naught is equal to 2, then y of t is equal to x of t minus t naught value is 2. That means here t naught is positive, that is x of t minus 2 means x of t is shifted to the right hand side by 2 units. That means here shape of the signal will not change. What is there at 1 added by plus 2, it comes at plus 3, 2 plus 2, it comes at 4, 3 plus 2, it comes at 5. That means shifted version of this signal is represented as this is 1 plus 2, it will become 3, 4, 5. This is the y of t. That means if x of t minus t naught, if t naught is positive, signal is shifted to the right hand side by the t naught value. Suppose if t naught is negative, if t naught is equal to minus 1, then y of t is equal to x of t minus of minus will become plus 1. In that case, signal should be shifted to the left hand side by t naught value. That is, in here it is 1 here. That is, shift the signal to the left hand side by 1 in it. What is there at 1, it comes at 0. What is there at 2, it comes at 1. What is there at 3, it comes at 2. That means this is 0, this is 1, this is 2. This is a shifted version of x of t. Okay, here signal is shifted to the left hand side. Okay, this is how the time shifting operation is done. Next one is, third one is reflection of the signal. Reflection means it is mirror image of the signal. Reflection. Reflection means it is, that is represented as y of t is equal to x of minus t. That is, x of minus t means what? Positive time will become negative time and negative time will become positive time. That is, what is there in the right hand side, it comes in the left hand side. What is there in the left hand side, that comes in the right hand side. Here. For example, if I have a signal like this, okay, if this is the signal, okay, this is 0, this is at minus 1, this is at 1 and this is at 2, this is t, this is the x of t. What is there from 0 to minus 1, you should write it at the 0 to plus 1. What is there at from 0 to plus 2, you should write it at the 0 to minus 2. Now the signal, what is here in this case, signal is there from minus 1 to plus 1, it is increasing line. What we should do here is just to change the time. Minus 1 will become plus 1 and 2 will become minus 2. That means you should write from minus 2 to plus 1. That is, its shifted version is written as this is plus 1, this is minus 2, this is minus 1, this is 0, this value, this value is 1 and this value is 2. This is the y of t, this is t. Okay, this is the reflection of a signal. Okay, that means reflection of a signal means what? Just you should take the mirror image of a signal. These are the three important operations on independent variable called time t. Next, suppose if you have an operations both shifting and scaling at a time, in that case we need to follow the presidency rule. That is very important. What is this presidency rule? Suppose if you have y of t is equal to x of at minus b, x of at minus b. In that case, here you have shifting operation and as well as scaling operation. You cannot do both at a time. As per the presidency rule, first we should do the shifting operation, then for the resulting signal, we should go for the scaling operation. That's why in this case what we should do, first you put t is equal to 0, put t is equal to 0, you will get y of 0 is equal to x of minus b, and put t is equal to b by a, you will get y of b by a is equal to b by a is equal to, you get x of 0. These two equations must be satisfied after doing shifting and scaling. This satisfaction is possible. This satisfaction is possible only if I do the shifting operation first and then scaling operation. That's why to follow this, what we should do here is, first let us take one intermediate signal. We'll do only the shifting operation x of t minus b. V of t is equal to x of t. That means x of t shifted to the right hand side by b units. Next, y of t is equal to that is v of at. After that shifting, we should go for the scaling of this. Okay, we should follow this presidency rule and have both shifting and scaling operations in the problem. Okay. Next, you see the operations on dependent variables. That is, dependent variables are amplitude scaling. That is, operations on dependent dependent variables. That is, dependent variables are amplitude scaling. First one is, that is, amplitude scaling. For example, if I have y of t is equal to c into x of t. That means what? C is the scaling factor. X of t is multiplied by this scaling factor value. Okay. Suppose if signal is exists from -2 to +2 with amplitude is 1. If C is 2, then amplitude will become 2. Okay. Next is addition of two signals is, suppose if you have x1 of t and x2 of t are two continuous time signal, then addition of those two signals is given by x1 of t plus x2 of t. Okay. Similarly, we have multiplication of signals. That is, all these will changes the amplitudes of the signals. That is, multiplication. Multiplication is given by, suppose if I have x of t and x1 of t and x2 of two signals, multiplication of these two signals are represented by x1 of t into x2 of t. Okay. Similarly, you have differentiation. Differentiation, that is, if x of t is a continuous time signal, differentiation of this is given by differentiation of x of t is with respect to time dt. Similarly, we have integration. That is, if x of t is the continuous time signal, y of t is given as integration of minus infinity to t, that is x of tau into d tau. Okay, this is the integration. In case of discrete, just you should take the summation. Okay, these are the operations on dependent variables. Okay, now we have learned in this class we have learned the operations, basic operations on signals, operations on independent variables, operations on dependent variables. Operations on independent variables are time scaling, time shifting, and reflection. And when you have both scaling and shifting, we should follow the presidency rule. Next, we have the operations on dependent variable, amplitude scaling, multiplying any signal by scaling factor, it changes the amplitude of the signal. Next, addition of two signals, x1 of t plus x2 of t is equal to y of t. To multiply two signals, resulting signal y of t is equal to x1 of t into x2 of t. We can differentiate the signal, that also changes the amplitude part. Y of t is equal to differentiation of x of t with respect to dt. And also integration, y of t is equal to integration of minus infinity to t x of tau into d tau. Okay. This completes the theoretical part of basic operations on signals. Next class, I'll teach the problems on this topic.